All right, so in this video, we're going to talk about combination of functions, okay? In this case, we're going to be talking about adding two functions together, subtracting two functions, multiplying two functions, or dividing two functions, all right? So we can call it functions f and functions g. So if we're finding the sum of those two, it'd be f plus g. If we're finding the difference, it could be f minus g or g minus f, depending on the order. F times g for the product, and f over g or g over f for the quotient, okay? So the notation we're going to use, if we're combining two functions via addition, it would be, we'd call it f plus g of x, okay, which is f of x plus g of x, and so on, okay? Now, one of the things you need to talk about is domain, all right? If the domain of a function f of x is set A, and the domain of a function g of x is set B, then the domain of the combination of those two functions is going to be the intersection of those two sets, okay? Remember, the intersection is what the two sets have in common, okay? So the domain for the sum is going to be the intersection of A and B, okay? The domain for the difference is going to be the same. The domain for the product is also going to be the same. The only thing that's different is with the domain of the quotient, okay? Remember, g of x, or the denominator, whatever functions in the denominator, cannot be 0, so you would have to exclude any values that would make g of x 0 when you're talking about the domain, okay? All right, so let's look at number 1. We've got a cubic function and a quadratic function. All right, we're going to find the sum, the difference, the product, and the quotient, and then we're going to evaluate all four of those at a value of x that is -2. Okay, well, first thing let's do is let's find the sum, difference, product, and quotient. So the sum of those two functions, okay? Let me go back. Let's talk about the domain first, okay? The domain is going to be pretty simple in this case because both domains are all real numbers, okay? So the first three, okay, the sum, difference, and product, the domain for those three will be all real numbers. The only thing that's a little different here is the domain of the quotient. Okay, what makes g of x 0? Okay, so x squared minus 4, we know +2 and -2 will make this function 0, so we would have to exclude those values from the domain of the quotient. Okay, all right, now let's find the sum. So f plus g. So we've got f of x here, we've got g of x here, we're going to add those two together. Okay, these are both polynomial expressions. We know when we add those, we just combine like terms. And I get x cubed plus x squared minus x minus 4. Okay, that's in standard form. All right, let's do the difference next. Okay, so I've got x cubed minus x minus this quantity x squared minus 4. Understand we're distributing a -1 there. Let's make sure our signs are correct. So we get x cubed, we get a negative x squared, we got a negative x still here, and make sure we've got a minus a -4 here, which is plus 4. So that's the difference of those two functions, okay? The product, we've got a binomial times a binomial. All right, so when I do the distributive property here, I get x to the 5th minus 4x cubed minus 1x cubed, and then -x times -4 is positive 4x. In the middle here, I've got like terms. Let's combine those, and I get x to the 5th minus 5x cubed plus 4x, okay? So that would be the product. All right, so let's find the quotient now. So we're going to start with f over g. So we've got x cubed minus x over x squared minus 4. Okay, now both of these can be factored. Okay, the numerator can actually be factored a couple times. We'll start with a GCF, okay, which leaves us with a difference of squares here. And in the denominator, we factored using the difference of squares pattern, x plus 2x minus 2. So let's factor the numerator one last time to get our answer. So we've got a x times x plus 1 times x minus 1 over x plus 2, x minus 2, okay? Remember earlier we talked about the domain. Notice that -2 and +2 have to be excluded from the domain because they make the denominator 0, okay? So that's how you find the four values, sum, difference, product, quotient, okay? Now let's go in and actually evaluate each of these at a certain value for x, okay? We're going to evaluate for x equals -2, okay? So to find the sum, f plus g, when x is -2, we're just going to take the sum that we found before, x cubed plus x squared minus x minus 4, and we're going to replace x with -2 for each of those three x's, okay? So we want to evaluate these two exponent expressions. Okay, so it gives me -8 plus 4. This becomes plus 2, and then this is minus 4. So when I combine all of these, I get -6. Okay, so when x equals -2, the function is going to spit out -6. Okay, all right. Let's evaluate the difference. Okay, so let's replace x with -2 in our difference that we found earlier. Okay, we're going to evaluate the two exponentials here. Remember, this minus and -2 becomes plus 2, so that gives me minus 4 plus 2 plus 4. Okay, so actually the sum and the difference of these two functions actually spits out the same answer when x is -2. Okay, all right, the product, let's evaluate that for -2. Okay, so we're going to plug in -2 into each of these x's that we found for our product. Okay, let's evaluate that. -2 to the 5th is -32. Okay, -2 cubed is -8. -8 times this -5 is +40. And then 4 times -2 is -8. So when I combine all of those, I actually get 0. Okay, so -2 would be one of the x-intercepts if I were going to graph this function. All right, now finally here, I'm evaluating the quotient when x is -2. Remember though, -2 was one of my excluded values because it made the denominator 0, okay? Therefore, when I evaluate the quotient at -2, I get undefined, okay? So that's how you find the combination of functions, sum, difference, product, quotient, and how you evaluate those for a specific value.